Hello, algebra students. And let's take a look at our 10.3 samples where we are interpreting and or creating two-way tables. So for our first sample, we're going to take a look at the table that shows students at a school in 2020. We can see immediately by looking at that two-way table that there's 300 students at the school. This will always be the total number of whatever we are surveying here. In this case, it's males and females who happen to be right-handed and left-handed. And so we're going to use the information that we see here in this table to answer two questions. If we just are pulling one of the numbers off the table, no work will need to be shown. If we need to do a calculation to answer the question, then we need to show that calculation in order to support the answer we're given. Question number 1, sample 1. How many female students are left-handed at the school? Well, this is one where we're just going to look at the table and pull the information right off, no work to be shown. So here's our females going across. We have 119 right-handed females at the school, 21 left-handed females. So that means that 21 of the females at the school are in fact left-handed. So we're just pulling that information right off and answering our question without any work showing. Second question, we're going to need to show a little bit of work. So on this question here, we're asked how many more male students are right-handed than left-handed at the school. So we're looking at the males only, so going across here. And we see that 136 of them are right-handed, but only 24 of them are left-handed. This is the case in any population, not just at this school, that you'll have far more right-handed people than left-handed people. That's just the way our genetics work. And so what we have to do on this one is work out the calculation, the difference between 136 and 24. This will give us the answer to how many more male students are right-handed. We have to take away the left-handed students from the total of the right-handed students. So that will be finding the difference. And so how many more male students are right-handed than left-handed? 112 of them. So if there's a calculation to show, you must show it in answering questions like this before you state your answer. All right, now we're still looking at the same table, two-way table. Draw a conclusion, it says, from the table about whether any particular female is likely to be right or left-handed. Give evidence for your answer. So you're going to state what you believe is true, and it has to be something that in fact is true based on the table. And then you're going to cite the evidence from the table as to why you're answering that way. All right, so let's look back at our females. We're looking to see, is any female, if we were just randomly to pick a female, are they more likely to be right-handed or left-handed? Okay, so looking at our females here, we see that 119 are right-handed, but only 21 are left-handed. So if we were just randomly to pick any one of these 140 females, we wouldn't know which one we're going to pick. Just draw a name out of a hat, use that idea to pick a particular female. It's much more likely that we would pick a right-handed female because there's way more of the right-handed females than there are of the left-handed females. So that's going to be how we're going to answer the question. And note, this is only one possible way to answer it, but it is important that you give a fact from the table as well as solid evidence based on the information in the table. A female at the school is more likely to be right-handed because 119 out of the 140 females are right-handed, but only 21 out of the 140 females are left-handed. Since 119 is much greater than 21, 119 right-handed females compared to 21 females, a random female is much more likely to be right-handed than left-handed. So the evidence is the piece of the answer that must be airtight, as well as the statement that you're making here. So this has two pieces, the statement of what conclusion you can draw based on what you're asked to respond to, as well as solid evidence from the table backing up that claim. Okay, so that's all for our samples. It's now time to move on to the quiz for this lesson, and we'll see you next time.